Hi, everybody. Today we're going to talk about identification and traceability of medical devices. This is one of those sections of the regulations for quality systems that is almost forgotten. It's even myself, I have trouble remembering what clause is that? What section of the standard is that? It's not one I have to reference a lot. It's something we sort of take for granted. But when you're implementing a brand new quality system and you start implementing UDI and you're thinking about inspection and line clearance, that's usually when this topic comes up. So I get a lot of really good questions, and we're implementing quality systems for several clients right now, and they're asking the same questions. So it's a great time to cover this topic. And next Monday, we're also, for anybody that's purchased our turnkey quality system, we're going to be doing a training webinar to explain how to revise, edit, and implement our identification traceability procedure. So I'll explain more details on Monday for those people that have bought that procedure. But this is going to be a high-level overview of what is identification and traceability, and what are some of the best practices that you should be looking at for implementing your quality system. So first of all, what is it? You have to identify your product, not just your product, but all the components to your product and the sub-assemblies throughout the entire product realization process. So a lot of people are like, well, what is product realization? What is that process? It begins at the beginning of clause 7 with planning and ends with you're actually shipping the product to the customer, and maybe they're even coming back to you with complaints or comments or some sort of post-market surveillance. So it has a big loop from the time you first get an order and you start planning the making of that product, even the design of that product, all the way through the end of the process with post-market surveillance and complaints and recalls and things like that. So you have to identify it throughout the entire process. So when I give you, let's say it's a catheter, I need to be able to tell you what lot of raw materials you used, what line I made that on, which operators used it, what machines were used, what day it was made, what packaging was used, what sterilizer I sent it to, what sterilization load was it on. All that stuff has to be identified. And the status of the product throughout it has to be identified. So my favorite example I give people for identification of status is, if it's yellow, it's to be inspected. If it's green, it's inspected and done. If it's red, it's in the bin down below and it's non-conforming. If it's right in front of me, it's what I'm inspecting right now. And that's an example that's specific to inspection, but it could be a production line. The parts over here are the parts that I'm going to build. These parts right here are the ones I'm building right now, and these are the ones that I just finished. And if you have a lean manufacturing environment, you probably have queues that are very, very small, little buffer quantities between the operations, and you want to try to make that buffer quantity as small as possible, so eventually you get to the ideal state of single piece flow. So that's an ideal. But some manufacturing operations require batches. For example, sterilization. You're not going to sterilize one device unless it's a really big device. So you have to have batches sometimes, like sterilization. Same thing for packaging. If you're packaging something on a blister machine, when you're packaging something on a blister machine, you might have a 4-cavity blister sealing machine. Oftentimes they call them shuttle machines. So if you have 4 cavities, you got to have 4 parts. So you got to have a buffer of at least 4 parts in between each operation. So I have my 4 parts, I put them in the 4 blisters, I seal it, and then I pass that on to the next operation, which might be labeling, for example. So I want to make sure that I have some way of identifying what is the lot of raw materials I'm working with, what is the status of the raw materials, any sub-assemblies along the way, and I want to keep the paperwork for that, if there is physical paperwork, with the product. Now, some companies, they've jumped ahead into the virtual world where everything is electronic. Even then, we typically have a router with barcodes, and we scan the barcode so we indicate, okay, this job is now entered this routing step. Operation 10, Operation 20, Operation 30. So even the companies with electronic quality systems, everything's electronic, they still typically have a piece of paper, a router, that tells me each operation has a barcode, and they have the ability to scan that barcode, and they know they've started that operation. And then when it's passed off to the next operation, they'll scan that, so you know what operation those parts should be at. So that's how we identify the status of something and identify what the location, identify what lot numbers there are at that location. And those lot numbers, they have to be recorded in your design history file. Device history record, DHR, or a batch record, or a lot history record. So those DHRs, lot history records, batch history records, that's all the same thing. It's just different terms for the same thing. Some people call them work orders or routers. Same thing. Now, you also have traceability. The level of traceability that's required for any device depends on the risk of that device and the technological characteristics of that device. If it's a very low risk device, let's say a syringe or a needle, maybe those aren't the lowest risks you can think of. Tongue depressors are a popular example. But let's pick a syringe or a needle or a catheter. These are on the low end of devices in terms of risk. They are sterile, but other than the issue of sterility and going through the skin, there's not a lot of things that go wrong with these devices. We don't think of needles and syringes generally being dangerous. We just think of them as hurting sometimes. So what level of traceability do I need for these? I need to know the lot level. What lot of raw materials? What production lot did I use? What sterilization lot did I use? That's the level we need. But if I had something that's higher risk, like a pacemaker, those are individually welded, laser welded titanium cans that are inserted inside the body. We have to track the battery, the circuit board. We have to track the software. We have to track the patient. We might do maintenance. We might do updates. You might have to do service on these. These are items, these are devices that are requiring traceability to the individual serial number. And they often have the serial number etched right on the part, maybe in laser. So these parts, they're either labeled with a serial number or they're etched with a serial number. We track the serial number of the board. We might have a serial number actually programmed into the software itself. We might track that for that. This is the patient that got that serial number. So that's what we talk about traceability. There's actually a subclause in the ISO standard that says you have to have traceability to the individual device for implants. So any active implantable device, like pacemakers, for example, you're required to keep that level of traceability. Any device you're going to do routine maintenance and service on, those are other items that over time, as they get service, they're going to become different from their sisters and brother parts that were made in the same lot. So now we have to keep track of them by serialization. A lot of companies that do reprocessing the devices do not serialize their parts. It's a really good idea to serialize, and now in today's day and age, when everything's barcode and everything's electronic, you might want to consider updating your process for on-demand serialization of your labels, because it makes it much easier to track how many times has this part been reprocessed. Instead of making marks on each part, you could just scan the UDI barcode on the device, because you're required to have it on the device now. No grace period anymore. That's long since gone. You have to have a barcode on that product. If they were serialized, then at the inspection process, when it's coming in to be reprocessed, you scan the part and say, oh, this has already been reprocessed 3 times, put it in the garbage. I don't even have to look for the little dots on the part. A lot of companies put little etchings and marks on a part to show how many times it's been reprocessed, and they limit it to often to 3 times. But that wouldn't be necessary if you had a barcoding system with serialization and you could tell me every single unit how many times it was reprocessed. And that would make it much easier to keep track. Oh, this serial number and 12 other serial numbers that might have been reprocessed different numbers of times were placed in the same sterilization load, and you could track it that way. So there are some big time savings and line clearance savings and all these things that we worry about when we do things as batches that could be much more streamlined with reprocessing if you serialize your parts. So think about it. If your device is a device that would be normally reprocessed, you might want to think about serializing the parts, and you might be able to do it on demand without any additional cost. Whereas if you do it in batches, it has a cost. It's going to mean some software reprogramming, but software, once you design your system for that, it's an installed cost. It's not an ongoing cost, and there are savings on the ongoing costs. So I highly recommend that to be a consideration. Add traceability to devices that are going to be reprocessed. Add traceability to devices that are going to be serviced. Anything that might have lots of software updates. Printed circuit boards usually have a serial number on them. Think about it for those parts. So you don't have to necessarily, it's up to the manufacturer to determine what needs to be traced and what doesn't. It's only implants, and particularly active implantables, that they push. You shall have traceability for serialization of those parts, but it would be really helpful if you did it across the board for anything that needs reprocessing or servicing. So, little piece of advice for your companies out there. I often put a reference in my identification and traceability procedures for the UDI process. UDI is detailed enough and complex enough that I probably need a separate procedure for it, especially for maybe a work instruction of data entry into the Good ID database. But I want to make sure I remind people that the identification of parts and the traceability of parts and the degree of traceability should be defined early, and that will also determine my UDI requirements as well. So I have to figure out identification traceability first, and then I can figure out how I'm going to go about UDI labeling of these parts. And ideally, you want everything to be computerized, barcoded, and automated on demand if you can. Those aren't necessarily requirements across the board, but certainly the technology is there. It's best practice. That's what you should be doing. So I hope that explains to people what identification and traceability is all about. I'm going to cover one more topic that's related: line clearance. If you've never heard the term line clearance, or you didn't know what it meant, let's go back to my example where I'm manufacturing a lot of catheters. If I switch the lot of raw materials, some people ask, well, if I run out of, let's say, a cap, do I have to create a brand new lot? The answer is no. Your policy as a company might be, we will, but that's your company policy. Your requirement is you keep track of what lots were used so you can have multiple lots of caps in there. The downside of that is if you have a recall because you had a bad lot, it increases the number of lots that you might have to recall. So it makes it harder to bracket. It makes it harder to investigate which lot is responsible. It makes it harder to do investigations of root cause and complaints and implement CAPAs. But you definitely are allowed to have more than one lot of a raw material in the same lot of production. It's not that if I only have 10 parts left, I can only have a lot size of 10. That's not how it works. You just have to make a note that I made 10 parts with this lot and the other 90 with this parts if I have a 100-piece lot. And because you don't have serialization, you might not have any way of knowing which of the 10 parts, and that's where you end up having to bracket the entire lot instead of just bracketing those 10 parts that had that lot. So that's the downside of having mixed lots of raw materials in the same lot of production, but it is permitted because all the parts in theory should be good. It just has consequences down the line. Now let's take another scenario a lot of people don't realize. What am I going to do when I switch the line over to a new lot? What some companies do is they literally clear the line. They take everything off their production line so it's completely empty, inspect it to make sure it's empty, and then put the new lot on the line. That's one approach. Companies that make a lot of lots and make very high volume, like kit manufacturers, they often will have physical dividers between lots. That's perfectly acceptable and works very well. You just have to train all your team. This physical divider is what we use to separate one lot from another, and we don't start work on the new lot until everybody's sure that we've cleared the line of the old lot, and ideally it's gone through the sealer and out to the warehouse. So there might be a slight interruption, but not as big of an interruption as if you waited till the whole entire line was empty before you brought new product to the line. So I'll see a lot of companies, they'll use something physical as a barrier. It could be a big red stop sign. Nothing wrong with that. It could be a box with the paperwork in it. That's acceptable as well. Whatever your company uses, whether it's a red traffic cone, whatever you pick, just pick something obvious, physical, that everybody agrees on. This is the point where we stop the line and make sure everything's cleared before we start to the next product. But everything on the other side of that cone can be the new product and we can be getting ready. Now, if I have things on demand and I have barcoding and I have an electronic system, I can have lots as small as 1. I can have lots as small as 10. So in these cases, it's possible to have a new lot number and have your lot sizes much smaller because everything's on demand. It creates more paperwork, but your paperwork's digital. So make it possible, if you go 100% electronic, to have smaller lot sizes that are defined by, oh, we switched a cap. We only had 10 parts left. We made a lot of 10, and then the next lot is 90 parts. That's perfectly acceptable to do that way. If you have an electronic system, it can be profitable too and cost effective, and everything can work smoothly. And if you are working in a reprocessing environment, you could have, you could have a little sign up there with barcodes with pictures, and you could just scan the barcode next to the picture. Oh, this is a catheter, scan the part, scan this, make sure the two barcodes match electronically, and now I'm doing a lot of 1. And then when I'm done with that and I put it over in this bin or in the garbage down below, the red bin, I grab the next part, scan, scan. It only takes a fraction of a second to scan those two, and the computer verifies the two would match. Then I do my job, which might also be appearing on the screen, and then it goes to the next operation. So if you implement these tools electronically with barcodes and embrace UDI for how it was designed to be used, it can make your internal business processes more efficient and allow you to work with as small lots as 1. So I highly recommend companies consider that. I've seen very few companies capable of doing that, but it's just because they're not thinking strategically about how to use lot numbers and identification, traceability, and barcodes and electronic quality systems efficiently and get the most value out of them. They look at it as something just to save labor in the document control department and something to modernize their quality system, but it can actually shrink your lot sizes down to as small as 1 and help you manage your inventory much, much better so it matches up with the customer demand is. It also will reduce the amount of delays in production. It causes a delay when you only have 10 parts and you need 100. You have to go count out 90 more. If your system allows you to work in infinitely small lot sizes as small as 1, things can go much, much faster. So I hope this helps people understand the whole concept of identification, traceability, how it relates to lot sizes, how line clearance begins. And as a bonus to people out there that have listened this long in the video, now we're going to discuss identification, traceability to software as a medical device. Totally different in some respects. Software as a medical device, a lot of people ask me, like, well, how do I do UDI for software as a medical device? How do I do lots in serial numbers when it's software? Well, the way most software companies work is they design the software, they validate the software, and they come up with a final version of software, and it's now cleared, okay? So I got us to that point, we're cleared, and we say, now we're going to release it. It has a version number on it. That version number could also have a build number or a build date. When you have build numbers and build dates, This is where you might have a different configuration for different customers. This customer wants English. This customer wants French. This customer wants it with all the modules of our software. This customer only bought the cheap basic model that's the starter. And they can add the other modules as time goes along. All somebody has to do is go in and change the configuration. In those situations, you could serialize. So you could have a serial number. It's the initial part of the UDI is the version of the software and the model. But the second part, the PI portion or production identifier part, tells you how it was configured for that customer. And it could be a language configuration. It could be modules that are activated or disabled. It could be how many stations are available. If it's a software, like say a central station software for a hospital with a whole bunch of different RF readers bringing telemetry data back to the central station. That would be one way you could implement that. But for these companies, they're like, well, how do we do the UDI on these parts? You could have just the same number for all of them, that everybody gets the same product. That's a simple configuration. Everybody gets the same configuration. But sometimes you have one software and you can configure it. When you have that, you need to have the PI portion is different. Some customers might have different options that they've added on. They might have had some customization. That's where you're going to have to modify that PI portion of your product. You might also have installations. So you have your base version of your software. You have somebody physically go on site and install it, or maybe you send it through the cloud, through a VPN network to the customer that's secure, and they upload it on their server. Every single time you're sending it over to them, the date that they sent it over and the system that they've installed it on, that would be their production identifier. So you might have that linked to a work order in some way, or a purchase order for that customer, or a license agreement. So for even software as a medical device, you still need to have traceability back to what version of software this is, but the production identifier may have no variation between customers, or it may have lots of variation where every customer has a different PI. And that would be more of a serialized approach. But because it's software, it shouldn't take a lot of work to just change that PI portion. So think about that when you're designing your software. A lot of times, or almost always, the UDI is supposed to be displayed on the splash or about screen. And a lot of companies have figured out how to put the license number or license key right in that information on the software. So you look at about information or system information, you can see what license it is or what key code they have for security reasons. That's the information that you need to link it to a specific PI for your labeling. So you want to learn how to implement probably a serialized approach for those types of software, and have a DI that tells you what version, what manufacturer, what model of software, but the PI portion is going to be the individual delivery to that customer or that individual workstation. So I hope that helps you. For those of you that were interested in how you do it for software as a medical device, I hope that helps. And that pretty much covers everything I've had to deal with in the past for identification, traceability for all types of devices. But if you have other questions, please put them down below in the comments, and I'll be happy to answer. I hope you have a great week. And next week on our live streaming on Friday afternoon, we're going to be talking about usability, and we've completely finished all our training on that. So we'll be rolling out a new usability training program for people and how they can get a certificate for usability after they've completed all of our training. So look forward to seeing you next Friday when we talk about usability training. Bye-bye.